Cool. Let's just have a quick look at finding the unknown sides in similar figures. Before that, we just want to be comfortable with this idea of a scale factor. So we know that similar figures have to be the same shape, but they can be different sizes. How different? Well, we want to compare the object and the image. Okay. So in order to find the scale factor, I can compare my image lengths. So I've got 10. And my matching object length is 5. And on the side here I've got 8, and on the side here I've got 4, and that will give me 2. So it's been enlarged by a scale factor of 2. Similarly, I can just find if a object has been reduced, and I can do that by, again, comparing the matching sides. So in my image now, I've got 5 on the bottom, and my object was 10. And on the sides I've got 4 divided by 8, that equals to half. So in this case my object has been reduced by a scale factor of half. Okay. So in this question here they asked me to find the enlargement factor. So they're telling me that the object has been enlarged. And so to find the scale factor, again we just want to look at the matching sides. And you've got a right angle triangle here, there's the hypotenuse and there's the base. And so I realized, okay, so this is going to be my image because it's enlargement. So I know it's got to be bigger, and I guess that's my object. And so I realized, okay, my matching sides are 8 divided by 4, which equals to 10 over 5, and that equals to 2. Okay. And the reason, I guess, why you do 2 ratios, so you can just confirm. Just having 1 ratio doesn't really indicate that as clearly. So use all the lengths that you're given in the figures. Again, similarly over here, this one's a little bit different. We're given 2 sides and there's 2 angles, but this time you can notice that it looks like the shape has been flipped. And whenever I get something like this, my preference is I like to redraw it so that they're, I guess, in the same orientation, so it becomes really clear which side is actually matching. So you can see you're given these 2 angles here, and so if I redraw this guy, so he's just been flipped over, so that 5 goes here and 8 goes there. Okay, and then again it's an enlargement factor, so I want to compare my image, which is the bigger one, and I can see now really clearly which sides are matching. So I've got 7.5 over 5, which equals to 12 over 8, which equals to 1.5. So it's been enlarged by a scale factor of 1.5. Great. Now that was for finding an enlargement factor, but what about finding the value of unknown sides in a pair of similar figures? And this time we still want to use that scale factor idea, but I guess the order that we put that ratio doesn't matter as much now. I'll show you what I mean. So they tell us that all the pairs of figures that we're given are similar, and so we can use this scale factor idea. And in this case you can see that we've got an unknown side here, x, and I guess, yeah, you can see that these angles here are corresponding, and so you can work out that these sides are matching too. So when you're trying to find x, what you want to realize is, okay, well, x over 12, because those are the matching sides, would equal to 5 over 20. Okay, and then again you can just solve for this. X will equal to 5 over 20 multiplied by 12, and that's just 1 over 4 times 12, which gives me 3. And when I said the order, I guess, doesn't necessarily matter, you could do this the other way. You don't have to have chosen x divided by 12. If I do 12 divided by x, okay, you can realize that x equals to 3 still satisfies this equation. Now the reason why I chose x divided by 12 was because it makes it easier to solve for x though. So think about that when you're finding the value of the pronumeral. Try and put the unknown value as the numerator. It will make it easier to solve your equation. Cool. Let's look at another example. So again, I've got an unknown side here, and you can see clearly it's a parallelogram, so these sides are matching. So I've got here x over 12 again equals to 24 over 8. And again, I can just solve for x really easily. So multiply both sides by 12, and that will give me 3 times 12, which is 36. So those ones are hopefully pretty straightforward. Sometimes I give you triangles that, or a pair of figures that look like this, where one's kind of hidden inside another. And if you look closely, you can see where the two triangles are. I've got this guy here. Now I'll redraw it so it's a bit clearer. You've got this guy. But where's your other triangle? You've got that bigger one as well. Now we want to be careful when I'm putting in the lengths here. On this taller side, I've got 2. What's the length in the bottom here? Well, I know that this length is x. I know that this length is 2. So if I'm putting them together, I just sum them. So that whole length would be x plus 2. And again, I want to use this idea that the figures are similar. I can realize, okay, how do I put my numerator on the top? Well, I want to have x plus 2 first. Which side is that matching to? Well, that's matching to that base there, 2. And that's equal to 2 over 1. And you can just continue to solve this like you would any other equation. You get x plus 2 equals to 2 times 2. Just multiply both sides by 2. X equals to 4 minus 2. X equals to 2. And then you can see that x equals to 2 would satisfy this equation here, because that means that this length is 4. Okay, and you got an enlargement factor of 2. Cool. Let's just do one more example. Now sometimes it won't be so straightforward. You can see that you've got 2 triangles here, but it's not that clear which sides are actually matching. So it's important that we just take some time and think about the information we're given. So you've got all these sides here. How do I know which one's matching? Well, you think about it. Go back to your angles cheat sheet. The first thing that you notice is you've got a pair of vertically opposite angles on this one. So you know that these two are equal. Now the tricky bit is realizing, okay, which side is corresponding to which with these lengths here. And again, you want to come back to your angles cheat sheet, and you see you've actually got this Z going on. You've got these alternate angles happening. Where exactly? Well, you've got one pair over here and one pair going this way. So I only need to put one of them in to be sure. If I put in those angles there, and now you can see a bit more clearly which sides are actually matching. If I redraw both of them, so this one's pretty easy. You just write it as it is. And then I want to redraw my larger triangle. The first thing I know is that that this length here is 12 because it's just been flipped, right? Because these are vertically opposite, so these are matching. And then, okay, I've got this angle equal to that angle, and this length here is 4, and so that means that this length here is 8. And now that I've redrawn it so that the orientation is the same, you can see clearly which ones are matching. You've got x divided by 4, and now I can use any of the other two sides. Let's just say 9 over 12. Okay, and then now you can just solve for x. You multiply both sides by 4. Okay, and that leaves you with 3 over 4 multiplied by 4. And so x would just equal to 3. And that's all you have to do.